complete nonsense. And if you speak it the way a German would speak it, it'll sound angry.
Yeah.
Der Käse ist in die Schule. Wo ist mein Taschenmesser?
Cool.
That is, the cheese is in the school. Where is my calculator?
Awesome.
It's great. I love it.
All right. How's everyone doing?
All right, yeah.
So, PA2 questions. First of all, let's start with those.
How do you want to go about alphabetizing them? How can you compare words like in alphabetical order?
So, check out your string class.
There's a string dot equals.
There's a string dot equals and there's a string dot compare to.
Yeah.
And
You
there's
compare stuff alphabetically.
and there's a thing called Wi-Fi. Get it?
Come on, this is the 21st century.
Yeah. I just need to like disconnect and reconnect sometimes when I move through the building.
Have you tried turning that
Don't have
on?
to. Yeah, exactly. Three times? 2 times?
Hmm?
What was the rule? 2 times? 3 times?
Turning it off and on again?
Yeah. Are you referencing IT crowd?
Yes. I am.
Okay.
I'm glad somebody finally gets the
Oh yeah,
reference.
yeah.
You have an N in your compare.
So you have a string, right? So it's in a variable like s. You can say s dot compare to parentheses and put in a second string, and it'll return same thing as string compare in C. It's an integer, and you look at its sign to know which one comes where.
Oh, okay.
And that one compares alphabetically.
They should be ASCII code based, right?
Yeah, I knew I could compare ASCII code based stuff. Yeah, I just figured that would give me like two very similar words.
So real quick test, we'll just run it on 2 command line arguments. We'll use the first argument's compare to method with the second argument. So if we say cat dog, it'll come back with -1, which tells you the first thing, the string itself was smaller than the argument that you compared it to. If you do x cat and dog, then you get a positive number, so the string is larger than the thing you're comparing it to.
Okay. And that always works alphabetically, like that one comes after that one.
Yeah, it always works. Not dcat. Famous x cat. It's comparing ASCII codes basically. So subtracting them. So if it's a plain old string, right? And be careful. Alright. So it looks like 30 is bigger than 100. So be careful if you try to actually compare numbers that are strings.
So you want to test and see if they're integers.
Yeah, it's just doing, and for PA2, you're just doing string comparisons. Right, so if you find a word 30 and you find a word 100, string compare says 30, comes after 100, that's what you do. Don't try to be fancier than required. All right, other PA2 questions? And remember, don't sort your words at the end, right? put them into your list, keep the list sorted at all times, and makes your life a whole lot easier. Sorting a list isn't particularly fun.
It's also faster just to list insert.
It's what?
It's also faster just to
Yeah, it's also faster to do it when you insert.
If there's anything there in less
Yeah.
sorting.
All right, so let's look at lab 2. So this one, you're going to actually hook some hardware up to this device, and this is kind of the hello world for that. So it's a little hard to see on here, but there's a little embossed 1 and 2 over here next to this header. So 1 is on top, 2 is on the bottom, and then it just alternates. Right? If you're in doubt, ask me for your unit, but it should say 1 and 2.
So it alternates?
So 1 is right here, 2 is right here, and then just continue the pattern 3, 4, 5, 6, 7, 8, 9, 10,
So just
all the way up to 39, 40. So there's your USB plug on the side. That's a great drawing, man. Frame that. All right. So for this lab, your main goal is to make an LED blink. Okay. So you should have a few parts in your parts bin. You can actually get away not worrying about resistors, but worry about resistors anyway. But if you're in a rush, don't worry about resistors. You can just slam an LED into 2 pins here and drive it directly. And this won't put out enough juice to burn the LED. At least so far it hasn't. So all you really need is an LED and just put it in the right holes. Write your code, make your LED blink. It's fun. So there's 3 experiments here. The first experiment is where you actually figure out how to work with the general purpose I/O system, how to compile and how to execute with the libraries that you need, and how to find the right pins to talk to. And then experiments 2 and 3 are doing some extra programming on top of that. Okay, but they're pretty incremental. So experiment 1, so some code for accessing the GPIO ports, and this is not your code for experiment 1. This is a piece of it, so don't type this in, spend 6 hours running it, and then say, I tried your code, it doesn't work. Okay, this is not the complete code. This is just a snippet that has the things that you will need to do in order to make the LED blink. So you need an import. Okay, so this up here gets you to the GPIO routines. So this is something called Pi4J, Pi for Java is the package name. So go ahead and import that, and then you want to do these 2 setups. So GPIO controller is a class that basically gets you an interface to the physical ports. So you just construct it by saying GPIO controller, pick an object name equals GPIO factory.getInstance. Okay, and in this case I call my object GPIO. That's the thing I can use to get access to individual pins on here. And we only need 1 pin. We're going to use the pin number GPIO04. And so GPIO pin digital output, object name pin is what I picked, equals, and then it's whatever object you used from the get instance as a provision digital output pin method, and you just pass it this thing raspi pin.gpio_04 if you want pin 4, for example. That's boilerplate, right? You're going to do that anytime you want to do output, or input. If you want to do input, you're going to provision a digital input pin. Okay, after you do that, you have this object called pin, and the 2 main methods that are of interest in that is the high and the low method. If you say pin.high, it drives 5 volts on the pin. If you say pin.low, it drives it to ground. That's all there is to it. Okay, and the code inside those classes does all of the work to actually get out to that connection. When you're done, do a GPIO.shutdown, right? Again, GPIO is this object up here. So use the shutdown method. When you're done, that frees everything up for the next time. Okay, compiling and executing. So to compile, you have to use this dash class path option. So Java C space dash CP space. And then you can list a series of things separated by colons. So we're saying dot, which means first look in my current directory for classes. That's the default. And then colon, and it says then look in this directory opt py4jlib py4jcore.jar. That's basically an archive that contains the class files that you need to do GPIO on here. So that's boilerplate, right? And then you just have the name of your Java file that you want to compile, whatever you called it. So this will be the name of your file. All right, that should compile. If you're getting errors from that, back up, check your code. This has got to be pretty much verbatim, right? Uppercase, lowercase, all that stuff matters. And this has got to be verbatim when you do your compile. So once it compiles, you want to hook up your LED in this case. So here's a picture. This is the same pin numbering that you have on here. So 1, 2, 3, 4, and so on. And GPIO 4, that's pin 16. And conveniently, pin 14 is a ground. So if you come back to your picture, basically you want to take this and hook up an LED. And the two leads on the LED, I think their spacing is 0.1 inches, which is the spacing here, so you just pop it in.
Convenient.
Yeah, and not coincidence. All right, so you plug that in, and anything you want to say here? Stuff we all said. Normally you use a 1K resistor, but we can skip that. Okay, to execute your code, same thing, you need the class path switch. So Java, right, dash cp dot colon same directory dot jar, and then whatever the name of your class is. And you got to use sudo when you run this, okay, because by default you don't have access to these ports. So you have to run it with sudo in the front, which says run this as a super user. And that should run your code. Okay, so what's experiment 1? Experiment 1, you basically write a Java program that waits for the user to type something in. And if they type in the number 1, you should turn the LED on. If they type in anything other than number 1, turn the LED off. Okay, it's about the simplest loop possible. Read from the user, turn the LED on or off, go back to the beginning, read from the user again. Right, and just keep doing that.
No exit of any sort.
Say what?
No exit of any sort.
You can exit on end of file if you like, or you can just let it run forever. Control C it when you're done. All right, so how do you do that? Well, you know how to read from standard in using scanner. And you can just say next line, and then see if the first character is a 1. Or see if the input equals 1 or whatever you like. You could do next int, but I'd avoid that because if you type something that's not an integer, it's going to confuse it. But open your scanner, do a has next line, get the next line, and see if they typed a 1. And if so, then call pin.high, otherwise call pin.low. That makes sense? All right, so that's experiment 1. Experiment 2, very slight modification. You're going to put in a delay. So this little snippet of code here, this method called mySleep, will sleep for t milliseconds. Okay, so if you call this with an argument of 500, it'll wait for half a second. And so your main program should turn the LED on, sleep for half a second, turn the LED off, sleep for half a second, keep going. Okay, so when you run this, sudo java-cp, etc., it lets you just constantly blink on and off by itself. All right, third experiment, slight tweak on that. When you run your program, first thing it does is say, how long do you want to wait between blinks or something like that, and the person types in an integer, that's the number of milliseconds to wait. So if they type in 500, it blinks on and off half a second. If they type in 100, it'll blink on and off 10 times a second. If they type 10,000, it takes 10 seconds to blink on and off. All right, so just building up levels of interaction with this. So 3 experiments. Once you've got them all working, or as you do them, get a sign-off from whoever's in the lab. So here's your sign-off sheet. Put on your group number, date, full names of the people in the group, and have them observe each of these experiments. So experiment 1 should turn on and off in response to user input. So show them 1 turns it on, 0 turns it off. Have them sign the witness line. Experiment 2, run it. It should blink on and off. They can witness that and sign. And experiment 3, blink it fast, blink it slow. Let them witness, have them sign off. And you're done. Good?
Good. Oh, I have a question for the experiment.
Yeah.
So it should ask for the user input once, right? How many
Just
times?
once, yeah.
Okay, good.
Just in the very beginning, say, you know, enter a time interval. They type
Okay.
something in, and then it just forever after it blinks at that rate.
Okay, cool, good.
Yeah, we'll change that in the next one.
Yeah, okay.
So we shouldn't check if they're gonna do it like extremely fast. It might short circuit something.
No, that's fine.
Should be fine.
Yeah.
Okay.
And don't worry about, you're the one demonstrating this, so don't worry about error checking and things like that, right? If you say, how long do you want to wait, and they say, ha ha, they shouldn't be playing with your pie, right? So no, seriously, don't worry about error checking for this. Let me tell you where we're going with our labs. So for lab 3, we're going to do the same thing, but while the LED is blinking, I'm going to ask you to be able to, at any time, type in a new number and have it change the blink rate. So it's blinking on and off half a second. You can type 100, hit enter, it starts blinking fast. You can go and type 2000 and it starts blinking really slowly. Okay, which means that while it's blinking, you're going to want to somehow know that the person typed in some input. And we can't do that very easily unless we deal with threads. And we'll be talking about threads by the time we get to lab 3. So that'll be lab 3. Lab 4, I don't remember what it does. Oh yeah, so lab 4, you're going to deal with an input switch. And as you may remember from 250 and 270, switches are not perfect. When you push a switch, it doesn't usually just go from open to closed, and when you release it goes back to open. There's bounce in there. So if you take this switch and you hook it up to this Pi and you say every time that you press the button I want you to add 1 to a counter, chances are when you push the button it's going to add 4 or 5 to it, right? Unless you're like really good about pushing buttons. So you're going to get errors in there. So one way to debounce switches is through software. So that's what you're going to do in lab 4, is you're going to write some code that figures out, is this really 5 button presses in 1/10 of a second, or is this bounce, right? And it'll debounce in software. Program 5, you're going to build a network. And you're going to work in groups of 2 groups each. And you're going to make a sender and a receiver pair. And using 3 wires, you're going to hook your Pi up to another Pi, and you're going to be able to send messages back and forth. That's the coolest lab.
Save the best one for last.
Yeah, yeah. Alrighty. So I'll post an ODP tomorrow. I'll post another one Wednesday probably. I was posting it this morning. I couldn't get it to work for some reason.
Yeah,
so.
I saw it.
Yeah.
I did, but sensor.
Yeah, it was too early. I copied the wrong file and stuff. So I'll post that tomorrow. But the readme's on /temp if you want to read it ahead of time. All right. Let's play with Eclipse. So how many people have Eclipse installed on their machine or have a plan to access it? Worst case, you can use Eclipse on the computers in the collaboratorium. So as I mentioned before, when you bring up Eclipse, you need to pick a workspace, and it'll force you to do that the first time. And everything you do in Eclipse is going to go in a subdirectory of whatever workspace you pick. So I suggest making this something that you back up regularly, okay, or that you push out to Git or something like that, as opposed to the default, which like on Windows ends up somewhere in some system directory and such. So put your workspace somewhere that you know about. Yeah. And you get this welcome window. Go ahead and close that out. And if you don't have this kind of view, go to Window, Perspective, Open Perspective, Other, and find Java. And it'll bring up something like this. All right, so everything is built on the idea of a project. So let's start a new project. I don't know what this is going to be. Just call it miscellaneous project. And as soon as you do that, you've got a bunch of subdirectories. Files that you create are going to go under source. Generally, you don't do a whole lot of working with any of the stuff outside of Eclipse. Okay, so I just created this project, and for me, it's under Files, Eclipse, Delete Me Too, and there's miscellaneous project, and there's source, and if I start making source files, they're going to end up under here. I would avoid ever tinkering with anything in here, right, unless you're doing it through Eclipse. You can do it, but it gets treacherous, right? And if you mess things up in the mind of Eclipse, your project may become unusable, and you have to find your source code and sort of start over again. So you start working with something in Eclipse, stick with it. So main thing you're going to do is make classes. So make your class, and I don't know, we'll call this my main, and we'll say go ahead and put in a public static void main. And there's our code. And then when you want to run it, there's a run button down here, or you can go under the run menu and make sure you save it. You can get rid of the nag message, and your console output comes out down here. Okay, so I'm going to close out these things because I don't need them. Make my windows bigger. And so now if we make a new class, I don't know, let's call this a rectangle class. Right, so now I've got two tabs, main and rectangle. So there's some rectangle code. Let's go ahead and add an area method. Right, and I'm doing very little typing here. Right, it's filling in a lot of stuff for me. It's filling in my curly brackets and my closing brackets and all kinds of other stuff. And I'm really just kind of typing the pieces that I actually care about. So I'll save this. So now I've got a rectangle class. So let's go back to main. So this should make 2 rectangles, and if I run this, it should do the expected. All right, so let's talk about exporting, because you want to figure this out before you actually try to submit PA2, right? And if you do this wrong, you can munge your project, so you want backups and stuff. So I've got my rectangle project, so miscellaneous project. I'm going to right-click on the project itself, and I'm going to come down to Export, and I'm going to go to General, and I'm going to say Archive File. Okay, this is really critical. There's a lot of different ways that you can try to export. So right-click on the project, Export, General, Archive File, say Next, and then tell it what you want the archive file to be. So you can browse if you like, and I'll just pop this in my home directory, and I'll just call this archivetest.zip. Don't change any of these other things, okay? They should all be set for their defaults. This should automatically be checked, this should automatically be checked, this should be checked. Okay, if for some reason those are unchecked, my suggestion is cancel out of this, go back, try it again. If they're still unchecked, right, manually check these, but unless you've clicked on them at some point, they should all be selected. So let me say finish, and it goes ahead and presumably it exports it. So what does this file look like? You don't really want to mess with this either, but if we were to look at it, it's got a whole bunch of stuff in it. It's not just my Java files. Okay, if all you see is your 2 Java files, this is not the export you want. Okay, so it's got a settings, it's got a bin, it's got a source, and it's got some other stuff in here. And the source contains your Java files. Okay, but don't monkey with the zip file. All right, so when you're done with a project, you can right-click and you can say Close Project. You can also say Close All Projects if you want, if you've got multiple ones open. Don't keep more than one project open at a time. Okay, it'll confuse things. So open a project, work on it, finish it, close it, and then open a second project if you want. Okay, the other side is to import this zip file, and this feels totally different. So go to File, Import, not Export, File, Import, and then still General, but don't say Archive File, say Existing Projects into Workspace. And this you do have to change. Instead of Select Root Directory, click Select Archive File, and then browse to the zip file. So it's under Home, it's called archivetest.zip. And it's going to give me a warning, some project cannot be imported because they already exist in the workspace. Okay, this is an expected warning. I'm trying to import miscellaneous project, and miscellaneous project already exists. So how do you do this? Well, there's 2 ways. One way is to delete this project, but I don't recommend that, because if you didn't do the export correctly, you've lost your project. So an easier way is to rename this project. And this brings up another thing in Eclipse, which is called refactoring. So in C, when we want to change the name of a file or the name of a variable, we just change it, right? In Eclipse, it will manage doing these changes for you, and it will try to do it in a smart way. So if you have a variable named height, and you want to change it to rectangle height, you can say refactor and say I want to make this change, and it will go through, and it won't randomly just change HEIGHT to something else. It'll make sure it's actually the name of an object, and it makes sense to change it there. So let's change the name of this project. So I'm going to right click. I think I have to open it first. So I'll double click to open it, and then I'll right click and say refactor and rename, and I'm going to call this miscellaneous project old. Okay, so now I've moved it out of my way, right? It's still got both files under the source. So I'm going to close this. And now I'm going to try importing that zip file. So this is something you do at the end after you've uploaded your project to Canvas. Pull it back down to your machine, right? Move this out of the way. Try to import that zip file and make sure it restores your project. This was happening in the bathroom earlier too. It's kind of annoying. Okay, so File, Import, General, Existing Projects into Workspace, select Archive File, browse to the file, Archive Test. No warning this time, that's good. And then say Finish. And if that works, I should have a new miscellaneous project. So open that up, come down to the source, make sure it's got all the parts and pieces, run it, make sure it runs. Make sure you're picking the main program and say run, and everything's good. Okay, so this is what we've done every class, right? Upload your project and then pull it back and go through all the steps to do what I'm going to do to test it. All right? I'm going to take your zip file, I'm going to try to import it, and then I'm going to try to run it. So that's your verification. All right, questions about that? Okay, let's talk about JavaDoc since we're here. So I haven't put any comments in my code, right? And I'm about to turn it in, and I got to rush through and I got to put in some comments, and they're going to have lots of typos because I'm doing this really fast, right? So you can do your commenting as you go, right? But you can get Eclipse to help you with adding comments to your project. So let's come over here. And I'm going to say /**, and I'm going to say this right before the beginning of my class. I'm going to say /**, and I'm going to hit enter. And it's making a little comment block for me. So it says author, and it's using my username, which on my machine is Nick. So I probably want to change that to something with my last name. And there's other things we can put here with an @ sign besides author. But basically you can type in whatever comments you want. And that's a comment, right? But it starts with these two asterisks after the slash. That's a hook, which this command called JavaDoc will use to know that this is a comment that it's supposed to use to create some documentation. All right, so so here's a rectangle constructor. Let's say /** and hit an enter. And it creates a block of comments here, including @ parameter H and @ parameter W. And this allows me to specify what these parameters H and W are for the constructor. So I can say something like create a rectangle. That's my description of the constructor. H, height of the rectangle, and W is width of the rectangle. And let's come down to the area method, and I'll say /** enter, and it's created another block of comments, including an @ sign return. So I can say calculate the area of the rectangle, and what it returns is rectangle's area, which is height times width. So I got some documentation here. Okay, I can come down under project and I can say generate JavaDoc. And the first time you do this, you need to tell it where the JavaDoc command is. And for me, I have it not in my regular path. I have it under, oh, looks like I might have it right here. All right, so say This is where it's going to generate it. So it's under that Eclipse directory. And I'm just going to finish. I'm not going to even look at any of those options. And it'll give me some messages here. And so now if I were to go into that directory, so remember it's under Eclipse, delete me to, miscellaneous project. Now there's a new directory called doc, and it's got all this stuff in here. And if I click on index, it brings up a page like this. And this is nice, pretty documentation about my class. And it's a standard format that's well understood. So there's the class. It's an object. It's called a rectangle. There's how it's defined. There's my little blurb about it. There's the person who wrote it. Here's a list of all the methods, what they return, and you can click on these and get down to the details of the method and so on. And I didn't put any comments about toString, but because toString was public, it made an entry in here about toString also. So I may require JavaDoc later on in the course. I'm not going to require it for now, but it's kind of nice to work with, especially as you're developing classes that you think you might be using again down the road. Right? This is nice for code reuse, so that you can remember exactly what you're supposed to put into a method, what you're supposed to get out of it, and so on and so forth. So questions about that? So play with it. There's lots of options.
Easiest web page I've ever made.
Yeah, yeah. And there's also an entry under here now for doc. And you can open up stuff in here and see it as well. But you can push this stuff out to a web page, right? If you're releasing something, you can put it on your Git, whatever you like, and that's just standard HTML. All right, so what else can we do in here? So we have switch statements in Java. So switch expression, and then a case statement says if I is equal to 1, the usual, followed by a break. And so on. And then when you're done, you can say default. And it's already put a closing bracket on me. Okay, so switches work like they do in C. You know about for statements, you know about while statements, you know about if then, else, and so on. All this stuff carries over from C, right? There may be minor tweaks in it, but for the most part, the syntax is pretty identical. So you should recognize it.
I'm a big fan of automatic indentation.
You are.
I'm a big fan of it.
Oh, good.
It's one thing I missed when going into.
Well, you can turn it on in most things. I mean, you can turn it on in VI.
I know you can like change the tabbing then.
You can set AI for auto indent.
Yeah.
Yeah.
What?
You can :set space AI, I think, for auto indent. It'll do everything. So let's go back to our scanner class, right? So So I've got some squiggly lines here, right? So hover on that, and it'll give you all the things you could do to fix this, and there's 7 ways you can fix it, right? Usually the first 1 or 2 is the one you want. So import scanner, gets rid of those, come over to file, import file, and now I got a blob under the whole thing, and it says unhandled exception, right? So 2 quick fixes available. Either add a throws declaration, which means we can say that this method is able to throw an exception, in which case it won't care that this call might cause an exception, because we're saying that the whole block of code, we understand it might throw an exception, but then whoever uses this needs to deal with the exception. Or we can put a try catch block. So let's just say surround with try catch, and boom, it writes all the code for you.
Oh.
Right? So there's your try, there's your catch, and as usual, I would move the declaration of your scanner outside. So file not found exception, e.print stack trace will print a nice little list of who called what. And then maybe we'll just return right there.
Why are we giving up you on the yellow squiggly lines? Like,
Okay, yellow squiggly line, probably because I haven't used SC and I haven't closed it yet. So resource leak SC is never closed. So I can suppress that warning, or I can go ahead and add an SC. And up here it's telling me that SC has been given a value, but it hasn't been used yet. So those are just warnings if they're yellow.
Yeah, you just do sc.close first.
Say again?
You just do sc.close first.
Yeah, so at the end of all this you can say sc.close, and then that squiggle goes away. And I got a new one because I don't have my semicolon yet. So there we go.
What is it, 84%?
I don't know, I was trying to ignore that. I don't know.
Oh, now it's gone.
Now it's gone.
I had something to do with this.
Yeah, that was weird. Oh, now I broke it. Void scanner, 84%. I don't know.
That's interesting.
It's 5/6. I don't know.
But what? Okay,
Who knows?
okay. Why not?
Oh, and I got rid of my return. So here it's complaining because SC might not have been given a value because I got rid of my return here. Right? So what's the possibility? Scanner, SC is a scanner. I try to assign it a value. Scanner fails to open, and so it comes down to my catch block. And then I fall through and I try to close SC, but SC doesn't have a value yet. Right? So it's really, really eyeballing your code closely. And that can be a good thing, or sometimes not. So if we just run that, it'll tell me file not found, test.dat, and this was the result of e.print stack trace. So it shows me everything that got called, starting with my main 27, called all this stuff, and eventually generated the exception. You don't have to print a stack trace, but it can be useful sometimes. I could just print a message, or I could just ignore it completely. All right, so that's a bit of a whirlwind run through of some features of Eclipse. Like everything in these courses, right, the more you mess with this stuff, the more sense it's going to make. And I could stand up here and lecture for 10 hours, and you're going to get more out of 15 minutes sitting in Eclipse and trying things, right? So do that. And tomorrow I want to start talking about something called Swing and Window Builder, and it's a way to create graphical interfaces. So I want to start working on that tomorrow. So if you've done some stuff with Eclipse before, then it'll make things make a little more sense. So go ahead and jump in if you like. All right, I will see you next time.